Bismillahirrahmanirrahim. Welcome to the second part of the fundamental theorem of calculus. In this part, we are speaking about the second part, which is complete the theorem of the fundamental of calculus. The first part, we said that if we are given a continuous function, then we can define a function g of x to be different integral from a to x. Just define in integral form where the derivative will give me f of x. In this part, say that if we have a continuous function f of x on interval a and b, then the different integral from a to b f of x equal to f or capital F of b minus capital F of a, where f is any antiderivative of f, that is a function f such that f prime equal to f. So the derivative of the capital F will give me f equal to antiderivative or the original function where we got the small f after differentiating. So if you combine the two parts, part 1 and part 2, we have the fundamental theorem of calculus. So let's suppose that f is continuous on cross interval a and b, then f g of x equal to the limit integral from a to x f of x, then g prime equal to f. Second one, if we have definite integral from a to b, not x this time, f of x equal to capital F of b minus capital F of a, where f is any antiderivative of f, or f prime equal to f. To apply this theorem, let's have some examples. We need to evaluate the given definition. We are now using the second part for these examples. Second part. I want to evaluate. Question number 25. I need to find the value for this definite integral 1 to 3 x to power 2 plus 2x minus 4 dx. So in the first step, we need to find the antiderivative for this one. Let's take them one by one. The question number 25. I have three terms, x to power 2, I have 2x, and I have minus 4. Later on, I'm going to state the rule for finding the integration of any function, or for at least for the polynomial. Now x squared, this function came from the function 1 over 3 x to power 3. This is my antiderivative. So I can say this is my capital F. Because if we differentiate 1/3 x to power 3, I will have x squared. Second one, 2x. The original function for this one is x to power 2. And minus 4 is minus 4x. How we found this? I will say it after solving this example. So we are finding the antiderivative for each term. It means the integration from 1 to 3 of x squared plus 2x minus 4 dx is equal to 1/3 to power 3 plus x squared. I'm not using this part. X squared minus 4x. And we need to evaluate it between 1 and 3. Which is equal to f of b, f of the upper limit minus f of the lower limit. This is equal to 1/3 3 to power 3. We are using the upper limit first. Plus 3 to power 2 minus 4 times 3. So this is the f of b. Now minus f of a. Now we evaluate at the lower limit. That will be 1/3 multiplied by 1 to power 3 plus 1 to power 2 minus 4 multiplied by 1. We are just replacing x by the upper limit and lower limit. Evaluate the function. This will give me 27 over 3 plus 9 minus 12 minus 1/3 plus 1 minus 4. So this is equal to 18 minus 12 is equal to 6 minus 3, or this should be plus there, minus 1/3. Open the bracket and change the sign. So it is 9 minus 1/3, that will be 26 over 3. So the value for this definite integral is equal to 26 divided by 3. So the idea again is to find the antiderivative for the given function. Then we evaluate that function at the upper limit minus the lower limit. So have another one. Take, for example, question number 27. 26 will be the same, 28 will be the same. 27. I have 4 over 5. These are the limits, or the terms. T to power 3. And I have minus 3 over 4, t to power 2, and 2 over 5, t. Now the antiderivative for this one is 4 over 5 t to power 4 divided by 4. Now let's think about the derivative first, then the integration. For the derivative, if we remember the rule of the differentiation, if I have d by dx of x to power n, the rule for the derivatives is given by n multiplied by x to power n minus 1. So in the derivative, we subtract 1 from the power and we multiply the function by the power itself. In the integration, if I have x to power n dx, the integration is the reverse of the differentiation. So x to power n, in the derivative, we subtract 1. For the integration, we will add 1. So it will be x to power n plus 1. We're adding 1 to the power. In the derivative, we multiplied by n. For the integration, we will divide by the power, which is n plus 1. It's just the reverse of the derivative, or of the differentiation. Again, in the differentiation, we are subtracting 1, multiplied the power by n with the power. In the integration, we add 1 to the power and we divide by the power. But for this one, provided that the power is not equal to minus 1. If it is equal to minus 1, this will be a special case and will be discussed later on. So we add 1 to the power. So plus 1 is equal to 4 and we divide by 4. This can be simplified as 4 will cancel 4, so it is 1 over 5 t to power 4. So this will be my capital F, or the original function, or the antiderivative, or f of t, not x. I said x should be t. The second one, same idea. We are adding 1, will be 3. So it will be minus 3 over 4 multiplied by t to power 3 divided by 3. So cancel 3 with 3. It is minus 1 over 4 t to power 3. Next one, power 1. So add 1, it will be 2. So this is 2 over 5 t to power 2 divided by 2. Let's cancel this 2. I will have 1 over 5 t to power 2. So the integration 0 to 2 of 4 over 5 t to power 3 plus or minus 3 over 4 t square plus 2 over 5 t dt is equal to, again we are using this. I will have 1 over 5 t to power 4 minus 1 over 4 t to power 3 plus 1 over 5 t to power 2 and evaluate it between 0 and 2. So this is equal to 1 over 5 multiplied by 2 to power 4 minus 1 over 4 2 to power 3 plus 1 over 5 multiplied by 2 to power 2 minus, now replace t by 0, it will be 0 minus 0 plus 0. I just take this 0 and plug it in the t. I will have 0, 0, 0 for the lower limit. So this is equal to 16 over 5 minus 8 over 4 is equal to 2 and plus 4 over 5, which is equal to 16 plus 4 is equal to 20 over 5 minus 2, that will be 4 minus 2, which is equal to 2. So the value for this definite integral is equal to 2. One last example. We can take 33 for this integral 33 from y over 2 to 0 of cosine. We can think about the trigonometric function and which function, if we differentiate it, we will get cosine. We know that the derivative of sine d by d theta of sine theta equal to cosine. So if we integrate both sides, we know that the integration is cancelling the derivative. So integration of cosine is equal to sine theta. So the antiderivative for cosine will be sine theta. So this is equal to sine theta, and from y over 2 to 0, which is equal to sine of 0, this is my upper limit, minus sine by over 2. We know that sine of 0 is equal to 0 and sine of pi over 2 is equal to 1. So this is 0 minus 1, which is equal to minus 1. So this is how to apply the fundamental theorem of calculus to evaluate the definite integral. Just find the antiderivative, then evaluate it at the upper limit minus the value at the lower limit, and that will give me the value of the definite integral.